Hi students, in last video we completed the detailed analysis and gunshot bits in modern physics. Now in this video we are discussing from simple harmonic motion. So students, in simple harmonic motion, in ECET point of view, from this topic there are 3 questions are asking. So how many questions are asking from simple harmonic motion? There is a weightage of 3 marks. In that 3 marks, I divided 3 sections. Section 1, I am explaining displacement, velocity, acceleration and time period and frequency in SHM. Now from this equation, they are asking different types of questions. So before starting, I will explain first formulas. What is a displacement equation in SHM? What is a velocity equation? What is acceleration equation? What is the time period and frequency? From that formulas, they are asking different types of questions. So first I will explain these 4 formulas. Students, first I am explaining the 4 formulas. Just now I told in simple harmonic motion there are 3 questions are asking. I divided 3 sections. In section 1, the questions related to displacement, velocity, acceleration and time period frequency. Here displacement equation y equals to r sin omega t. What is the displacement equation? Y equal to r sin omega t. What is r? Amplitude. Similarly, velocity equation. Velocity means, you remember here, velocity is equals to derivative of displacement. Derivative of displacement, that is dy by dt. Then if you differentiate this displacement equation with respect to time, then what is the velocity equation? That is r omega cos omega t. Now that velocity equation I converted into again in displacement equation, that is v equals to omega into under root of r square minus y square. This is displacement equation. If you differentiate the displacement equation with respect to time, see here differentiation of sin cos, therefore what is the velocity equation? R omega cos omega t. Students, remember very important equations. Velocity equation in terms of cos, r omega cos omega t, in terms of displacement omega into under root of r square minus y square. Similarly, acceleration, here 2 definition. One is acceleration is equals to derivative of velocity, that is dv by dt. So the derivative of velocity, the rate of change of velocity is known as what? Acceleration. Again v equal to what? Dy by dt. Hence acceleration is equals to, I am writing d square y by dt square. So remember, simple harmonic motion is a second order differential equation, because here acceleration equals to what? D square y by dt square. If you differentiate displacement 2 times, or if you differentiate velocity 1 time, then what is the equation will obtain? That is acceleration. Here acceleration equals to minus r omega square sin omega t, and again in displacement acceleration equals to minus omega square y. You remember these 4 formulas: displacement equation, velocity equation in sin or cos, and velocity equation in displacement. Similarly, acceleration equation and again acceleration equation in displacement. After that, here 2 standard bits we are considering. One is mean position, another is extreme position. What is mean position? Means where the value, here I am considering displacement. See, mean position I am considering y equal to 0 because r value 0. At extreme position the height is r, then y equal to what? R. So, remember at mean position the amplitude y equal to 0, at extreme position the displacement value is r. Then the velocity equation at mean position, see here y equal to 0, then it is r omega. And again at extreme position y equal to what? R, then r square minus r square becomes 0. Therefore, velocity at extreme position 0. Similarly, acceleration. Here acceleration equal to what? Minus omega square y. At mean position displacement value 0. Therefore, acceleration is also 0. And finally, at extreme position acceleration equals to what? Minus r omega square, or if you consider only magnitude, that is r omega square. So, students, you remember displacement equation, velocity equation, acceleration equation. At the same time, what are the values at mean position and extreme position? To remember velocity and acceleration, you must remember displacement at mean position is 0. Displacement at extreme position is r. So, this is displacement, velocity and acceleration. Now, again you remember frequency and time period. Here the relation between frequency and time period, that is frequency f equal to 1 by time period. From that equation omega equal to 2 pi f, here I am writing what? 2 pi by t. By using this concept, here I am expecting some important question, gunshot bits in simple harmonic motion from these 4 topics. What are the 4 topics? Displacement, velocity, acceleration, time period and frequency. We will discuss from question number 1. See students, now we are discussing first question. A particle is executing simple harmonic motion and it is described by x equal to a sin omega t. Here equation is given as what? X is equals to a sin omega t. So, what is this equation here? Displacement equation is given. Now is asking what is the maximum acceleration? Is asking what? Acceleration. So, from the definition, acceleration A is equals to, in terms of displacement, I am writing that is d square x by dt square. What is the acceleration equation? In terms of displacement, d square x by dt square. Or dv by dt also, here displacement is given, that is why we are solving d square x by dt square. So, first I am derivating the equation. We know that differentiation of sine is cos. So, dx by dt, I am writing here dx by dt, that equals to a, that is constant, differentiation of sine cos omega t into omega. This is the equation, dx by dt. Now, again I am differentiating with respect to time, that is d square x by dt square. Then I am writing here a omega constant, differentiation of cos omega t, that is what? Minus sin omega t. Differentiation of cos minus sin into omega. Therefore, here minus a omega square sin omega t, minus a omega square sin omega t. So, here I am considering this is acceleration equation, but is asking what? What is the maximum acceleration? Here from the maximum acceleration, here we are considering only the value, because sine value is 1. So, acceleration maximum is equals to how much? Omega square a. This is the answer. So, when displacement is given, how to find velocity equation means, you remember dx by dt, derivative of displacement with respect to time. Suppose they will ask acceleration, then what is the formula? D square x by dt square. This is first type of question. Now we will discuss the second question. Now I am explaining second question. When the displacement of a particle is in SHM from mean position is 4 centimeter, then the force acting on the particle is 6 newtons. Then the force acting on it when its displacement is 6 centimeter from its mean position. So here the question is related to force and displacement. Here the question is related to force and displacement. So here from the definition of simple harmonic motion, I am writing force F is directly proportional to displacement. Force is directly proportional to displacement. Now is comparing, therefore I am writing equation F1 by F2 is equals to y1 by y2. F1 by F2 equal to what? y1 by y2. See here students, when the displacement is 4 centimeter, I am writing here, when y1 is equals to 4 centimeter, then what is the force is given, that I am considering here F1, 6 newtons. Now is asking, if the displacement is 6 centimeter, if the displacement is 6 centimeter, then what is the force? F2 is how much is asking. Then I am substituting all these values here. F1 that is 6 newtons, F2 we are finding now, y1 it is given as 4 centimeter, y2 it is given as 6 centimeter. So 4 by 6 means what? That is 2 by 3, and F2 equals to how much? 2 2 ja 4, 2 3 ja 6. Then F2 equals to, see here, 3 6 ja 18 by 2, that equal to how much? That is 9 newtons. So what is the force? When the mean displacement is 6 centimeter, answer is 9 newton. Therefore option 4 is correct. You remember here force is directly proportional to displacement, but according to SHM definition, actual equation, force is, direction of force is always opposite to the displacement direction, and F is equals to what we discussed, that is minus K into Y. What is K here? Restoring force constant. Remember its units and dimension formula also. So this is about second question. That question is related to conditions of SHM. Now we are discussing next question. See students, this is third question. A particle is executing linear simple harmonic motion of amplitude A. When the displacement is of the amplitude, then the fraction of kinetic energy. This is kinetic energy question related. Here kinetic energy means, you remember kinetic energy equals to, I am writing, of m omega square into r square minus y square. This is the formula. So here a particle is executing simple harmonic motion of amplitude A, and when the displacement is of the amplitude, then the fraction of kinetic energy is asking. So here the displacement is half of the amplitude. So here I am writing r equal to A, because amplitude is given as A, and when the displacement is half of the amplitude, that means r equal to A I am writing, y equal to A by 2 I am writing here. Then of m omega square into r square I am writing A square minus y square A square by 4. So, I am taking LCM of m omega square into 4a square minus a square, that is 3a square by 4. Now, I am writing this term is equals to of m omega square a square into 3 by 4. See students, of m omega square a square into 3 by 4. What is of m omega square a square means? That is total energy. Therefore, here answer that is 3 by 4 times of total energy. Hence, in 4 options, option 2 is correct. So, first write kinetic energy equation. In that you substitute displacement condition. So, what is the condition is given? When the displacement is half of the amplitude. So, here what is the answer? 3 by 4. Now, we are discussing fourth question. The question is, the maximum velocity of a harmonic oscillator is alpha and its maximum acceleration is beta. Then its time period will be. So, here is given maximum velocity. Here V maximum is equals to, from equation I already explained, mean position and extreme position. So, maximum velocity formula here r omega, that is here alpha. Similarly, maximum acceleration A maximum equals to r omega square, that is given as beta. See, read it. The maximum velocity of a harmonic oscillator is alpha and its maximum acceleration is beta. So, r omega equal to alpha, r omega square equal to beta. Now, I am writing r omega square is equals to beta, and this r omega square we are writing r omega into omega, r omega into omega. What is r omega? Alpha. So, alpha into omega is equals to beta. Alpha into omega equal to beta, because r omega equal to what? Alpha. We know that omega equals to 2 pi f and is asking time period. Now, I am converting into time period 2 pi by t. 2 pi by t, that is omega, is equals to, I am writing beta by alpha, beta by alpha, because alpha into omega equal to what? Beta. From that omega equal to beta by alpha. Now, cross multiplying here, beta into time period t is equals to 2 pi alpha. From that time period t equals to, I am writing 2 pi into alpha by beta. This is the answer. So, in 4 options, option 1 is correct, that is 2 pi alpha by beta. So, students, here you remember 2 formulas. What is maximum velocity? That is r omega. And what is maximum acceleration? That is r omega square. From that we are finding time period. Sometimes they will ask frequency also. Then you write omega equals to 2 pi f. So, this is the answer. Now, we will solve next question, that is 5th question. See here students, 5th question. The displacement of a particle executing in simple harmonic motion is given by y equal to 8 into sine of 0.4 pi t plus pi by 2. Then is asking what is the time period in seconds. Is asking what? Time period. So, here you consider displacement standard equation. What is the displacement standard equation? That is y equals to a sine of omega t plus phase difference phi. This is displacement equation. Here if you compare this equation, what is amplitude is given as 8, what is the phase pi by 2, and what is omega value is given as 0.4 pi. Now is asking what is the time period. So here we know that omega in terms of time period, omega is equals to, I am writing 2 pi by time period. This is the formula because it is asking time period. So omega equal to 2 pi by t, that equal to, I am writing 0.4 pi. How much is given? 0.4 pi. Then both sides pi will be cancelled. Then 2 1s are 2, 2 2s are 2, 0.2. So 0.2 pi, 0.2 into t is equal to 1. From that t equals to 10 by 2. So what is the answer here? 5 seconds. This is the answer. In 4 options, option 3 is 5. This is the answer. Sometimes he will give an equation. Then you compare the given equation with the standard equation. Then they will ask amplitude, they will ask omega value, sometimes they will ask frequency value. Similarly, sometimes they will ask time period also. So this is such type of question. Standard equation, compare with given equation. Then you will get the required answer. Now we will solve next question. This is 6th question. The maximum velocity of a particle executing simple harmonic motion with an amplitude of 7 millimeter is 4 meters per second. Then the time period of oscillation is. The maximum velocity of a particle executing in simple harmonic motion with amplitude is given 7 millimeter. So what is the amplitude is given here? 7 millimeter. And what is the velocity given? V maximum is given as 4.4 meter per second. This is the values are given. Then is asking what? Time period. Now what is maximum velocity equation? Means maximum velocity is equals to A omega. Equation what? A omega. Here omega equal to, I am writing A into 2 pi by t. This is the equation. Now maximum velocity is given as, I am substituting the data, maximum velocity is given as 4.4 and the amplitude is given as 7 millimeter, 7 into 10 power minus 3 into 2 and pi approximately I am considering as a 3 by time t. Now see here, I am simplifying this equation. 4.4 equals to 7 into 10 power minus 3 into 2 into 3 by t. From that I am cancelling here 2 1s are 222. So here otherwise you can simplify easily. One more method I am explaining. See here. Again I am writing the equation. So what is V maximum? Again I am writing A omega equation, that equal to I am writing A into 2 pi by t. So what is V maximum is given? That is 4.4 meter per second. Amplitude I am writing 7 into 10 power minus 3 and 2. Here I am writing pi equal to what? 22 by 7 into 1 by t. See here students, if you write like this, we will get easily answer. That is why. Sometimes the data is given related to 22 7. So I am simplifying now. This numerator denominator 7 will be cancelled. 22 2s are 44. So I am dividing, that is 0.1. Then 0.1 into t is equals to how much? 10 power minus 3. Then t equals to 10 power minus 3 by 0.1, that is 10 power minus 2, that equals to how much? 0.01 second. This is the answer. So, formula is simple, but here simplification is somewhat complex. So, he is given only maximum velocity and amplitude, but is asking time period. So, here the data is given like this. See, amplitude is given in millimeters, that is why I am writing in 7 into 10 power minus 3, and velocity is given as 4.4 meter per second. They asked time period, because in time period omega equal to 2 pi by t is there. Now, here especially this type of question you write pi equal to 22 by 7, because in data 44 is there, 7 is also there, that is why what is the answer here? That is 0.01 second. Now, we will solve next question. Here this is a theoretical question. So many times they asked conditions of SHM. From that, in simple harmonic motion, the restoring force is always directly proportional to displacement. F directly proportional to y, hence option 4 is correct. Now, we will solve next question, that is 8th question. This is also theoretical related question. The acceleration of a particle executing simple harmonic motion when it is in at mean position. See here student, the acceleration of a particle executing simple harmonic motion when it is at mean position is. So, here acceleration of a particle is what? Minus r omega square. Here at mean position means the displacement value is, I am writing minus omega square y. Here displacement value is what? 0. Therefore, acceleration is also what? 0. This is the answer, because at mean position what is the acceleration? 0. Next question. In a simple harmonic motion, if a simple harmonic motion, it is represented by, here this is simple harmonic motion equation given, d square x by dt square, actually this is dt square not dy square, d square x by dt square plus ax equal to 0. Now, I am writing this equation, d square x by dt square is equals to minus ax, minus ax. See here, this is a simple harmonic motion equation. Here d square x by dt square, I am writing what? A is equals to minus ax. D square x by dt square equal to what? A. So, d square x by dt square plus I am writing A equal to minus ax. Then we know that A is equals to equation already we studied, that is minus omega square x. This is displacement acceleration equation in terms of displacement. Now, compare these two equations, acceleration equals to minus ax, acceleration equals to minus omega square x. Here do not confuse, I am changing this is into alpha, otherwise both are A, actually this is what? Alpha. So, alpha, then what happens? Alpha equals to omega square, alpha equals to omega square, then omega equals to root alpha, and omega equals to what? 2 pi by t, that equal to what? Root alpha. Finally, time period t equals to what? 2 pi by root alpha. This is the answer. T equal to what? 2 pi by root alpha. Next question I am explaining. If x is the displacement and a is the acceleration of a particle executing simple harmonic motion, then it is a time period. Again the same type of question here. So, I am writing here acceleration A is equals to, I am writing omega square x. Acceleration equals to omega square x, I am writing. Then omega square equals to what? A by x. From that, omega equals to under root of a by x. This one. Now is asking time period. So I am considering time period equation omega equals to 2 pi by time period. 2 pi by time period, that equals to under root of a by x. Then I am cross multiplying here. See, t into root a is equals to 2 pi into root x. So finally time period t equals to 2 pi into under root of x by under root of a. So finally t equals to 2 pi into under root of x by a. This is the answer. So students, compulsory one question is asking from these topics. Not this type of question, at least you remember formulas and the conditions at mean position and extreme position. Solve more such type of questions, then you will get compulsory one question from these 4 topics: displacement, velocity, acceleration, time period and frequency. In next video, I will explain one more type of question in simple harmonic, that is what? Simple pendulum gunshot bits or simple pendulum expected question. So అప్పటి వరకు ఇవన్నీ జాగ్రత్తగా ప్రాక్టీస్ చేసి మీరు కాన్ఫిడెన్స్ తెచ్చుకుంటారని ఐ విష్ యూ ఆల్ ది బెస్ట్.